All right, we are back. Oh, so let's see you have for me here. All right, so I've seen 2 and 1. I see 2. All right, so let's see. So in this equation, in this case, the first thing that you want to do is so everything goes to the left side, and A is going to be on the right side. I think is the easiest order here to follow. So first thing that you want to do is to add both sides by 3. And that will give you 2 here. A, all these stay the same. And 3 get cancelled. Also, I didn't do that, but we can solve this first. So what is goes here inside, it is -1, all that squared, and then 2 equals A. 1 becomes positive because of the exponent being even. So at the end we can get A. Oops, what? A becomes what? Okay. A becomes equal to, okay? And this A is the one that we were looking for. All right, so A is equal to Tristan. Check what you did there. The actual value is 2, the correct value is 2. All right, but thank you for participating. All right, so how do you finish this? Well, you go here and you submit the final answer. The final answer should be A. You put here 2, and that is the value for the leading coefficient. And that's it. Any question? All right. So what is the written word here? Well, all the steps that I did. Obviously this part now, this is just an explanation. So step number 1, identify the vertex, putting the vertex there together. And then second part, solving for the leading coefficient, just select step 2.1 is selecting the point. Step 2.2 is solving for A. And then your final answer is presented here. Any question on this one? All right. This exercise here is where you need to find the zeros of a quadratic function. And this is going to, right now I'm going to show you how to solve this, but later on units that we cover on test number 2 is where you are going to see the reason behind, or you are going to see what a zero is, and how we use the zeros in a more general context. All right. So right now, what I'm going to do is just to show you how to find the zeros and what are the zeros for a quadratic function. Right. So here you want to remember you want to have or to know 2 things. Either one is going to help you. You need to know the quadratic formula, or you need to know how to factor quadratic equations. All right. So we need to find the zeros, and the equation that we have is y equals x squared plus 8x minus 20. First thing that you are seeing, my first question for you here. What form are we seeing here? Is this the standard? Is this the standard form or the bracket form? It is the standard, Amanda. We are seeing three terms, one with x squared, one with just x, and the constant term. All right. So with that, what is the value of the coefficient A, coefficient B, and coefficient C? Okay, A, B, and C. You need to be able to identify those values. What are those? I have here 1, perfect, 8, and negative 20. Okay. So what are the zeros? The zeros, the zeros of a function so zeros of a function is no other than the x-intercepts of the function. So we know, so we have the coordinate plane here, right? Oh, this is not what I want to use. I want to use pen. So this is our graph, right? Anytime the graph touches the x-axis, it is okay, Rachel. Yeah. You can watch the recording later. Thank you for letting me know. So anytime the graph touches the x-axis, that is an x-intercept. What is important about an x-intercept? Well, we do not know here exactly what the x value is, but we know that in all the x-intercept, the y value is going to be always equal to 0, right? So that is what we are going to do. So that's what we are going to use, because what we have is the equation of the quadratic equation, and then we are going to look for the zeros or the x-intercept. So what are the zeros of this equation? And the meaning of that is that what value of x makes what values of x give us y equal 0. In other words, we can go here alright, so we go here, and instead of having y, we put the value of y, which is 0, and then the challenge now is to solve for x. Okay, so now we need to solve for x. And this is not so easy to do because we have a quadratic equation. So what we have is an exponent or a power of 2 there, and that's not easily as working with a linear equation. When we are working with a linear equation, the only thing that we need to do is to add or subtract or multiply or divide. And now, because we have an exponent that is different than 2, we have another layer of difficulty, if you will, here, and then we need to start using other tools or skills or theories or theorems in order to solve for x. This is not so easy to do, so we need to use another techniques, right? The first technique that I'm going to explain here is using the quadratic formula. All right, and the other one is more an algebraic technique, which is factor. Okay, so got the formula by factoring this. I'm going to start with the quadratic formula, and it is important to know the coefficients, to identify the coefficient for using the quadratic formula. So the quadratic formula, when you are going to use the quadratic formula? Whenever you have the standard form of a quadratic equation equals to 0, okay, so you are solving for x, you are looking the 0 of the equation, you can use the quadratic formula. You need to have the standard form, and all the equation need to be equal to 0. If what you have on the other side of the equation is not 0, you cannot use the quadratic formula. Okay, you need to have 0 equals a quadratic formula or a quadratic equation in a standard form, right? And that is going to, our quadratic formula is going to be the following. It's going to be minus b plus minus b squared for ac, all this divided by 2 times a. Do you remember about this? Tell me on the chat if is this the first time that you are seeing this? All right. So you see that we are using B, C, and A. So let me just do the color that we've been using here. So that C, that A, that B are the coefficients. Okay, like I mentioned, like I said, we are going to talk deeply about the zeros of a polynomial in test number 2. Okay, so when we are working with test number 2, I'm going to give you more information about what is a real zero and what is a complex zero and so on. But right now, we want to focus on how to identify the zeros of a quadratic equation, right? Another thing that it is going to be important, but more for test number 2, is going to be what goes inside here, or the value that it is inside here. That value it is, or that expression b squared minus 4a is called the discriminant of the quadratic formula, and it's because that value is going to place the x value here, or the zeros, as real zeros or complex zeros. Okay, but that is something that we are going to talk later in the semester. Right. So right now, what we want to know is how to plug in those values and to solve this. So those values are here. Okay, so we have the value for A, which is the big one. We had the value for B, and we had the value for C. Okay. Go to your calculator or notebook and plug in those values and evaluate the value for X based on those numbers. Okay. I'm going to explain how to do this, but I'm going to give you 1 or 2 minutes so you can practice how to use the quadratic formula here, and then we are going to compare our results. Okay. So I'm going to turn off my webcam and I'm going to mute myself for 1 or 2 minutes. All right, so you have seen, or you can see on the screen that I just substitute those values. This is something that you want to practice because you don't want to lose points, because by this time we are going to use probably our calculator, right, to verify those numbers. Yes, you need to show all the steps, but if we have that tool in hand and we can use it, why not, right? So we're going to use our calculator, and you need to be able to input those numbers correctly in the calculator and knowing the value that the value you are getting is the correct one. Okay, so you want to practice how to use your calculator. The one thing that I want to talk about here is about what is the meaning of that plus minus. The plus minus in this situation is that we are going to get two values at the end, two x values at the end. Again, the meaning of that, we are going to talk about that later on test number 2. But that plus minus means we are going to have one value when we add, and we are going to have another value when we subtract. Okay, so here what we do first, we solve first the discriminant. All right, so we have here 64 minus plus 80. Right? All these divided by 2. And then we have x equals 98 plus minus. This is 4, 14. All this divided by 2. We go to our calculator, and then we solve a square root of 144, that's 12. Remember the plus minus, that's important because now that at this point we are getting two different values. Okay, we have the plus minus there. So we are getting the plus minus, the two values because of the plus minus. So when we add together, that means that we negative 8 plus 12, all that divided by 2. And when we subtract, means negative 8 minus 12, all that divided by 2. And here we are getting the two values. So 2, if I'm not wrong, negative 5. No, 12, 20. No, 20 divided by 2 is 10. Right, there you are. And at the end, that's the answer that you want to give. X equal positive 2 and negative 10, and you submit that on Alex. So those are the zeros, or the x-intercept of that equation, and that's how we get those using the quadratic formula. So that is what you are seeing here, is the written word that you should present. The calculations, you can confirm that, or you can use your calculator, but you need to be able to write down each step. Okay? You are not going to from here. You're not going to jump from here to here. Okay? At least I want to see some steps between the initial part and the final answer. Okay? Any question? So the other option is, if you know you're able to factor the quadratic equation, and you are going to be able also to solve this as well. Okay, so we got this here. And what we are going to do here is to rewrite this equation as the multiplication of its linear factors, of two linear factors. All right, so I'm not going in detail how to go from this to here. But if you need help, I'm not going to in detail now. But if you need help on how to factor a quadratic equation into two linear factors, let me know, and we can meet after I finish explaining this example. I can help you on whatever you need from here, from the factor part. All right. So you can remember FOIL. I do not know if you call this FOIL factorization. I do not use FOIL because I never learned how to do that by using FOIL, but if you can recall, this is basically the FOIL factorization. I believe that's how you call it. All right, so here what we need to do is to find two values that multiply together to get 20, and those same value we need to add them, and we need to get 8. Okay, so two values that we multiply them together and we get 20, negative 20, and those same values that we add them together and we get 8. All right. Another thing that it is important is that if we have a negative sign here, this negative sign here is telling us that one of these is going to be positive and the other one is going to be negative, right? So which one? So we know that if we multiply negative 2 times 10, we are going to get negative 20. And if we add those same numbers, we get positive 8, right? So that is the linear factorizations, all right? Because here we have a multiplication. It means if at least one of these is 0, the entire equation is 0, because 0 times anything is equal 0. So here are the two options, or x plus 10 is equal 0, or x minus 2 is equal 0, right? And from here we get that x is negative 10 because this is a linear factor. We can just subtract both sides to get the negative 10, and x is equal positive 2. And yes, Tristan, those are the numbers. Now in terms of the solution, it is positive 2 and negative 2. And see that we have reached the same values. Okay, positive 2 and negative 2. So here there are two options to solve this. Or you can use factorization, or you can use the quadratic formula. Either one is correct. So now you will choose in this which one is better for you, which one is the easiest for you. All right, there is everything work for both methods, for factorization and for the quadratic formula. Any question? All right. So find the intercept is the same as finding the zeros. Okay, so if you see on the exercise that they are asking for the intercepts, you will do this. Obviously with the function that the exercise gives to you. This one is very straightforward, but might throw you off because it is basically what we did, but in the other direction. Because here now we have the zeros, right? You have seen me that if I take the quadratic formula and I do the factorization, or if I take the quadratic equation and I factor the quadratic equation into linear factor, I can get the zeros, right? But now we are going backward. The zeros, then the exercise is telling me that the zeros are x equals -13 and x equals -2. And what we want to do is to create the equation based on that information. So this is going to be very straightforward. A linear factor linear factor, you are going to construct two linear factors here, and you are going to follow the following. So x is equal r. R is representing the 0, right? If x is equal r, the linear factor is going to be x minus r. And I'm going to explain this to make more sense to this. So for the first x, we have x equal -13. So the linear factor that belongs to, or the linear factor that correspond to x minus equal -13 is going to be x minus 13, or minus -13. We simplify this and we got x plus 13. All right, you can skip this step, just taking the opposite value of that value there and x minus 13, see? And then from x equal -2, again, we take the opposite value of -2, and the linear factor is going to be x plus 2. So those are the linear factors that correspond to those zeros. So how are we going to use them to get the equation of the function? Well, we multiply them together. And that's it. That's the equation. Yes, you can go and multiply everything else, but the exercise is not asking enough for multiplying them together. So that is the equation. That's it. Okay. If you multiply this, you are going to see that you are going to get a quadratic equation. But that's how you construct the equation of this function using its zeros. Okay. You turn those zeros into linear factor, and then you multiply them together. Here is the written work for that exercise. Okay. So the last three exercises are word problems, and I'm going to explain this one. There are other word problems. There's one word problem of related to optimization. There is another one. The one that is related to optimization is this one. So here, what you want to do is this is the quadratic equation here. You know what? I'm going to explain this one because there are a few steps that you need to do here. All right. A vehicle factory manufactures cars, right? And the unit cost, the cost in dollar to make each car depends. That word is important because now we are creating a relation between one variable, which is C, and second variable, the number of cars that are made. The number of cars that are made are represented as X. So C, the cost of making a car, depends on how many cars are made. And the relation is given by a quadratic equation. So here is the quadratic equation that relates the cost of creating a car, so C, and how many cars are made, cars and cost. All right. So the input here is how many cars are made, and the output is the cost of the production of a car. And what we want to find is the minimum unit cost. What is the minimum unit cost? So minimum C. And my first question for you is, is it possible to get, or is it possible to find a minimum value for C based on this equation? That's the first answer that we need to, that's the first question that we need to answer. It is possible to find a minimum value. Tristan, you said yes. Anyone else? Is it possible to find a minimum value? Okay. Why is it? It is possible, yes, but why? Yes, it is possible, but why? The main coefficient, it is positive. So the main coefficient A is 0.1, so this is greater than 0, so it is positive. And it means that the parabola opens up, so we have a minimum value there in the vertex, all right? So now that we know that, basically what we need to do is to find the vertex, the minimum value. To find the vertex, so it's getting the minimum value. First, we need to find the location, which is X, and then we need to find the actual value, which in this case is not Y, it is C of X, because we are using the name of, or the letter C to represent that. So this is the standard form, right? What is the formula that you are going to use to find the location? Is there a formula to find the location of the vertex here? What do you think? Is there a way to get that the X value of the vertex? Don't worry about the actual values. Just, is there a method to identify the location? Okay, my question is, let me okay, so that is the vector form, Dylan. Madeline, that's correct. Okay, let's go back here. Our exercise is giving us the quadratic function in a standard form, right? The equation that we have there, it is in standard form. And our exercise, the way we solve our exercise is to identify the minimum value. The minimum value of a quadratic equation, of this quadratic equation, occurs at the vertex, right? In order to get the minimum value of the vertex, we need to do one thing first. We need to identify the location of the vertex. That is the X value of the vertex. And like Madeline wrote on the chat, what we are going to use is the following formula. Minus B over 2A. Getting B and A from the equation. So those coefficients are there. So once I get the location, then I can identify the value of the function, the minimum value, by plugging into X what I get here. Okay, from step number 1, where we identify the location of the vertex, we use that value into the equation to get the actual value of the function, which in this case is the minimum value. All right, keep that in mind. You have standard form, you need to find the vertex. First, identify the location. And very important to understand the question, because sometimes, let me see what is the question. What is the minimum unit cost? The question is about the minimum unit cost, all right? There are two questions here. It could be what is the number of cars that we need to make, or the factory need to create in order to have the minimum unit cost. But that's a different question. The question here is, what is the minimum cost? So in order to reach that question, we need to answer first, how many cars they need to make in order to reach the minimum cost. So that means, in terms of unit number 4 of quadratic equation, what is the location of the vertex? What is the x value of the vertex? Knowing the x value of the vertex, then we can get the value of the function, right? Careful with word problems. It is important to understand the question, what we need to reach to answer the question of the exercise, all right? So standard form, and to identify the location of the vertex, use minus b over 2a, right? Whatever that value is, plug that value into the equation to get the value of the function, okay? I'm not going to solve it completely because I want to focus on the second exercise word problem that we have here, but that's how you solve this one, right? And the written work is going to be basically these 2 steps. X equals solve for x, and then plugging in x into the equation. Okay, so this is the last exercise I'm going to discuss, and this is a very classical exercise that you are going to see here, and you are going to see on your next math class, and so on. You are going to see this same exercise in so many ways, in so many times during your academic career, when you are taking math classes, because you are going to see how this same exercise can be solved with different techniques or technique for math, yeah. This exercise is related to optimization. Right now we are going to solve this exercise knowing how to identify the vertex of a quadratic function. Later on precalculus and calculus, you are going to learn about derivative, okay, derivative, and you are going to use that for optimization, all right? And you are going to solve this exact exercise with derivative techniques, okay? That they are very related to what we are doing here, right? But this is important. You are going to remember this same type of exercise when taking those math classes and talking about optimization, okay? Here we are going to talk about optimization, and we are going to solve it using what we know from quadratic functions, okay? Using the properties of a quadratic function. It is going to be on the test, it's going to be on the quiz, it's going to be on the final. So this is something that you need to know how to solve it. Here, I'm going to give you a guide on how to solve this type of exercise, okay? But you are going to see this many times in our class, and you will see this. I can guarantee this exercise on the quiz and on the test, okay? So you need to know how to solve this. We solve this exercise in 3 steps, in 3 parts. Let's start with reading it. So what we have here, Frank has 120 meters of fencing. Okay, important information. Okay, so the important thing here is this 120 meters of fencing. He will use it to form 3 sides of a rectangular garden. Second important information, we have 3 sides, a shape of 3-side rectangle. We have 3-side a 3-side rectangle, right? The 4th side will be along a house and will not need fencing. Alright, so let's break down this into what we are going to do. Yeah. All right, so this is the part when you want to use your imagination. In order to solve word problems, we need to be creative. I never been in this situation where I have a 120 meter of fencing and I need to create a 3-side rectangle of using that fencing. So now my mind is going to take a big part of solving this exercise because I need to be creative. I need to imagine me creating this scenario and knowing everything about that, because that's the thing of with what word problems. We need to be able to get into the context of the word problem to have a better understanding of what is happening there, right? So my best representation of my mind right now is getting 3 lines, and if I put them together, right, this is the amount of fencing that we have. So we have 120 meters of fencing, right? But we are going to break down those 120 into 3 pieces to create a rectangular shape. 3 sides of a rectangle. If I can put this. Okay, come on. Something like that. All right. Let me erase this one. So those 120. Now I'm going to create a 3-side rectangle with that amount. And this is the rectangle. This is my rectangle that I have here, right? We know that the 4 side is not going. We are not going to use the 120 meter of fencing for the 4 sides, right? Because we have a shape here, a rectangular shape. Whatever goes inside is what we are going to call the area of that rectangle. So here the area. Okay, and I know that this and this side are made of or are built based on the fencing that I have of this 120 fencing. Okay, so now it is important to use the variables because we do not know how long this side need to be in order to create this rectangular shape. The only thing that I know is because this is a rectangle is that these 2 sides, the length of those 2 sides are the same. Okay, so because I'm using X and Y now just to represent, I'm going to use Z instead of Y. Z I think is better. I'm using X and Z as a variable to represent how long these sides are, knowing that the 2 sides on left and right, they have the same length because it's a rectangle, right? All right, so now the question that we need to answer is what is the maximum area, or what should be X and Z in order to get the maximum area. Okay, so we need to figure out how to break down those 120 meters into 3 pieces. 2 of them are the same with the same length in order to get the maximum area. So this is a problem of optimization. And yes, we're gonna start like x equal 1. So we have 2x, two pieces of fencing with 1 meter, and the rest is going to be 118 meters. Yeah, we can start doing that and calculating the area, 1, then 2, but that's going to take all day for us. So we are not going to do that. What we are going to do is to use the mathematical techniques that we know in order to solve this exercise in a very timely fashion way, right? We are going to take advantage of our knowledge to solve this problem. So what we need to do first is we need to create a function that give us the area of this rectangle. So the first thing that we need to do is to create the function. So A, create a function. Okay, so we are going to use A of x to represent that function, the function that represents the area. Create a function for area. I should put here, create a function for okay, so we're going to create a function that represents the area of that rectangle. So how do we do that? What we know that we have a rectangle, and we know that the formula of the area of a rectangle, if this is height and this is length, is going to be multiplying just height times length, right? In our rectangle, we have, instead of h, we have x, and instead of L, we have Z. All right. So based on our information, we can create that function, x times z, and x is the input, right? So we are done. Well, not quite yet. What's the problem here? The problem is that now our function has 2 different variables, but the input of our function is just x, not z. So right now we have a problem, because z, there's no way that we can get z. So we need to rewrite z, or we need to find an equation that represents z, but in terms of x, right? So z needs to depend on x in order to use it in our function. Okay, so this is the first step. But now, what we know about our exercise? Well, we know that the amount of fencing that we have, that the fencing that we have is equal 120 meters. And we are using 3 pieces of that fencing. So that means if we add together x plus z, all this is equal to 120 meters. I can simplify this as 2 times x equals z equals 120. Oh, so we have x and c here in this equation, and we need to write z in terms of x. That means that I can use this equation here to have an equation for c, because now if I move this term x to the left side, so that means I'm going to subtract both sides of the equation by 2x, I am seeing this here. Oh, so z is equal 120 minus 2x. So this is an equation that represents z in terms of x. So using that information, I can go here now. And now I can replace z with 120 minus 2x. And by that point, I have finished. That is my equation. That is my function. All right? I can go further, and I'm going to distribute this x because I want to show you what type of function we have here. So 120x minus 2x squared. And this term here, it is important because this term here is telling us, oh, this is a quadratic function. So let me rewrite this, or let me change the order of this so we can compare this with what we have learned. So I know that the leading term now is going to be negative 2x squared. The second term is going to be 120x. So this looks like something that we have learned, but not quite yet. There is something missing. What is missing here? Or what do you think I want to represent or resemble with the equation that we have here? Can you guess what I'm trying to do here with this equation? Okay, what I'm trying to do with this equation is to just have in my mind, wait, this is a quadratic equation and this is in standard form. And this is important because knowing that we have a standard form, we have some techniques to work with the standard form. Okay, we need to remember that we can get the location of the vertex and the vertex itself. All right, so at the end, this is the equation. But since the constant term is just 0, we can cancel it. Okay, so I'm just going to erase that. And this is the answer for question number A. Question number 1. What is the function that represents the area? And here it is. Okay. So now we have that part. Now, the second question is about what side length x gives the maximum area. The first thing that we need to answer here, or the first thing that we need to check here is if this function, can we get a maximum value from this function? Okay, that's the function that we have. This is a quadratic function. The leading coefficient is negative. It means that the parabola opens down. Hence, yes, the vertex is going to give us the maximum value. So yes, we can get a maximum value with this equation. Now, x is the input of this function. And the question is about what is the x value that gives off the maximum area. How can we get that? How can we get the x value of the vertex? How can we get the location by the x value? How can we get the location of the vertex? What formula do we need to use? What we need to use? Exactly what we have there. Minus b or 2a. Okay, see why this is important. Knowing that we have a standard form, now we have this in our hand. So, what is this value? So b here is 120 and a here is negative 2. So when we solve this, what is the value that we're getting? So 120 over 4, so that's 12, and 4, that's 3, so 1 is 30. So we have 30. And we have two negative. They cancel each other. Why? What is the meaning of having a positive here? Is it? My question is, would it make sense for any situation where this value is negative? What do you think? Can this value in some situation could be this value negative? X equal 30 is talking about the length of that rectangle. In real, if you put yourself and think on in a real life situation, how can you tell that the length of something is negative? So that is not possible, right? So that is, this question or this answer makes sense to the context that we are working on. And that's a very important thing to always think about. My answer needs to make sense to the problem that I'm working with, or to the context that we are working on, right? So since X is representing the length of one side of the rectangle, this is equal to 30 meters. And positive here, being positive, it is important. It is a key concept here, because if we got a negative value, that means that the answer doesn't make sense to the context of the exercise, right? So always think about the context of the exercise. Your answer needs to make sense with the context of the exercise. Well, now that we know that what is the location of the vertex, so what is the side of the x length that gives the maximum area, now what we need to answer is, what is the actual maximum area? Well, we go here, we have an equation for the area. We know what is the input value to get the maximum here. And then this is just 120. Okay, the x value are going to be substituted with 30. All right, and then this is 120, 30, I believe. Yeah. And then we solve this. Solving this is 900. And then this is plus 120. Okay, we can check that just in a moment. I think this is this. I think I'm doing something wrong here. Well, let's use the calculator just to make sure that all my numbers are correct. Okay, perfect. And then obviously 2 times, yeah, 900 is 18. 30 times 30 is 900. Okay, that's correct. And this is just, if I know wrong, 1,800. And we can verify that with the calculator. Okay, see how I'm using the calculator? Whenever I have doubt, I just go to our calculator just to make sure that my numbers are correct. Yeah, and they are correct. And that's my final answer. The maximum area will be 1000, I think 1800, how you read this? 1800 meter square. And that's my final answer. All right? Yeah, Halima. All right. Again, I'm telling you, you are going to see this exercise in the quiz. You are going to see this exercise on the test. You are going to see this exercise on the final exam. You have the guide on how to solve this, and you have also the written work here. Obviously, you don't need to draw the rectangle, but you need to present this equation. Okay, how you get the equation for z, and you need to let me put here what you need. Everything from here is what you should put on your written work. Okay, how you get the equation for z, how you get the equation for the function, how you identify the location of the vertex. So in that case, it would be this part. This is written work, and then all this is written work, because that is you calculating or evaluating the function with the location of the vertex. All right, and yes, you are going to see this on the quiz and the test. All right, so here you have a guide how to do this. This is being recorded, so if you have questions or you have doubt, you can go back and watch this part, and you get all the information that is needed to, in order to solve an exercise like this type. Okay, today I took like 1 hour more than it was supposed to take, but I wanted to go over all this detail because this unit, it is important for test number 1, and it is important because it is the introduction of what we are going to do on test number 2. In my opinion, test number 2 is the most difficult test that we are going for this course, and it is because we are going to enter to an abstract concept of polynomial, of functions. All right, so basically we are going to do exactly the same here, but with all the different type of polynomials. So linear, quadratic, then cube, and so on. And you are going to see what I mean when we start working with polynomials. But this is a good introduction of what we are going to do on test number 2. So this unit is important. You have 9 days before the test, so you want to organize your schedule in order so you can go over all those topics and make sure that you are ready for the test and for test number 2. Okay, because test number 2 is going to be very like unit number 4, where you are going to present with an equation, and you need to get the zeros and all the information that you can get from that equation. All right. Any question? Any question that you have for me?
I have a question just about my camera when it comes to the testing.
Okay. Yeah. Those questions, we're going to talk about those type of questions. Those questions in a moment. A question regarding the class, unit number 4.
I don't have any questions about unit number 4.
Okay. So Madeline, I believe you are the one who's talking. Just stay after I finish here. I'm going to click stop here. Justin asking, are there any form of practice test we can prepare us? Yes, Justin, that is a good question. And here on the calendar, you are seeing that. So today is 27, right? So we are done with unit number 4. What you are going to see next after you finish unit number 4 in Alex, you are going to see in Alex two assignments. The first one that is due on Tuesday, but you can start working with that after you finish unit number 4, is test 1 catch up. Test 1 catch up is, now you know that in Alex, the units are locked down after the due date or after you finish them. So now in test 1 catch up, all the units are going to be open for reviewing. So when you have this, if you have missed topics on the previous units, you want to go back to those units and to finish those topics. That is going to raise up your grade in Alex, right? So that you have that opportunity to go back to finish any topic that you have missed. Also, there's a second Alex homework, is test 1 review. So you will have an homework that it is a test 1 review in Alex. More than that, also we have worksheet of the day 10-4. The worksheet of the day, the title of that worksheet of the day is test 1 preparation. So if I can get here that. So this is the next worksheet of the day that you are going to be working on, all right? And this is a review of all the topics that are going to, this is a review for test number 1, and here you can see that you have that exercise that I just finished discussing. It is here, all right? There is not all the type of exercise in this review, but this is complementary to the review that you are going to see on Alex, right? So using test catch up, test review, and the worksheet of the day for test preparation is all the practice that you will need for getting ready to the test. On top of that, if you want to continue and doing more practice, just reach out to me and we can set up. Well, we have 2 days for reviewing, because let me go back to our calendar. So we are going to meet on the 29th. The 29th is going to be our first review day, and also Monday 4th is going to be our second review day. So you want to go those days and have questions for me. Those days, because our review, I'm not going to record those days. I'm going to make an announcement about those, what we are going to do those days. But make sure that if you have questions and you want to review anything from test number 1, participate on either one of the 29th or the 4th with your questions, okay? And those are the days for reviewing and practicing. All right. Any other question?
On the participation log, I messed up when to turn it in. I forgot to, doesn't matter about the date, because I did mark off the other stuff, but I forgot to change the date. Is that fine, or?
Yeah, let's talk about that. Let me click stop here.